Hi. So since we're talking about backprop and since we've seen how we differentiate, the linear layer, how we calculate the gradients with which we update the weights, how we calculate the gradients that we send to the previous layer, we need to understand how to kind of tie all of this together. And for this, I recommend that we, go deep into one of the frameworks. And the choice of the framework today, in my opinion, is very clear. It's PyTorch. And I have done this myself. I have written code for Torch. So this is CUDA code that I have written for Torch 7. This link works even today. Just go to this link. You'll see my name here. I also co-authored this paper which has thousands of citations called Theano. So this was the Theano framework, and Theano is a Python library for fast computation of mathematical expressions. And you see, you also have my name here along with the institute that I was affiliated with, which was IIT Bombay, where I used to teach in the CS department. So the point that I'm trying to make here is that we will go deep into one of the frameworks, which is PyTorch, and there are, so from Python you call C. And then from C, you call CUDA. And I want us to be familiar with this entire stack. And we will also write a PyTorch equivalent ourselves. And this is what it will look like. So this is just, the parent, the module, right? And again, because I didn't want to show you PyTorch because you only learn when you do it yourself, I'm showing you Torch 7, but they're very, very similar. So this is the parent class, the abstract base class. And from this abstract base class, there are interfaces defined. There are these different functions in the class defined. The class has some state variables, and we will do the same when we define our different modules. And let's say then the fully connected layer or the linear layer or the convolution layer is essentially derived from this abstract base class. So what will your class have, what will each of your class have, and what will the parent class have? The parent class will essentially own these state variables. So what is the state variable? Grad input, right? So this is the grad input that this will own, and this will also own the output, right? So you remember what is grad input and you remember what is output, right? So your module will own those two things. So every module, remember, owns the grad input and it owns the output. So this is the output, right? And grad input is essentially the gradients that it is giving to the previous layer. So now these are the state variables. These are the only things that this class owns. Now there are these different functions. So let's look at them. So the module is an abstract class which defines fundamental methods necessary for training a neural network, and module contains, like I said, two state variables, the output and the grad input. Now we have, like I said, two main functions, the forward and the backward. And forward, what it takes as a parameter is input and computes the corresponding output of that module, right? In general, input and output are tensors. So this is the forward function. The forward function takes in this input and it returns the output. So update output essentially calls this another function, and this another function essentially returns the output. So this returns the forward function returns the output. It doesn't so this is the self.output, and the self.output is owned by this class. So this is what it returns. Now let's not worry about this, you will see when you define it, and then this is the backward, right? So the two main functions, like I mentioned earlier, the forward and the backward. And in the backward, look at what we are doing. We are performing backprop steps through the module with respect to the given input. And backprop steps consist of computing these two gradients. Remember, the gradient of output with respect to input and the gradient of output with respect to weights. And this is what we are doing right here, right? So we call the update grad input. So this computes, so the update grad input. So this computes this function, and then the update grad parameters, right? So it basically, grad input is this one and grad parameters is this one. And this is all that there is, right? And this is all that you will and every module of course also clears the accumulated gradients, because every time you do a backprop you have to clear your accumulated gradients. So this is all that you will do yourself. So this will what your parent class look like, and then every module you will implement these functions, and you'll start with the fully connected, which we already looked at, and we also know how to do the backward. And then if it's not, let's say, a ReLU, if it's not, let's say, an activation function, if your module has parameters such as the fully connected layer, this function, remember this update parameters, will also update the parameters according to the accumulation of the gradients with respect to parameters accumulated through the backward calls. So one thing I must mention is when you call backward, it doesn't automatically update the weights. You can keep calling backward multiple times and it will keep accumulating the gradients. It will keep adding to the gradients. And then you need to call this update parameters to explicitly update the weights. And this is why we also have that zero parameter, the gradients, right? Because we keep on accumulating, and that is why we also need to zero it out. And when you call this function, all it is doing is, you see here, it's essentially doing, parameters equals parameters minus learning rate into the gradients with respect to parameters. So these gradient with respect to parameters that is already accumulated. Yeah. And that is it, and this we will then apply to those various building blocks. We will start with the fully connected layer because we already looked at it in more detail. We'll do it for the convolution, max pooling, ReLU, cross entropy, and so on. And once we implement it from scratch all by ourselves, I think we'll be in a very solid place to really understand what is going on under the hood for frameworks like PyTorch. And this is what it looks like, right? So once we have created these different modules, we can then use these Lego blocks, these different modules, to then build like really complicated networks, and in this case, Lego buildings. Looking forward.